This is Mr. Wright. Today we're going to go over how to simplify radicals. So in order to simplify radicals, you first have to know what your perfect squares are. So you determine your perfect squares by squaring numbers. So if I just type in my calculator like 1 squared, I'm going to get 1. 2 squared means 2 times 2, I get 4. 3 squared, 9. 16. 25. So again, when you square something, that means you multiply the number times itself. 6 times 6 is 36. 49. 64. 81. 100. So most of the time when we're simplifying radicals, these are the perfect squares that we're going to use. You could keep going. Sometimes you may run into these higher perfect squares, but most of the time it's going to end up being like the smaller perfect squares you end up using, like the ones I just went over. So 121 is a perfect square, 144 is a perfect square, 13 squared is 169, 14 squared is 196, 15 squared is 225. So we'll just write all these down on our paper to make sure that you have them all. 16 squared is 256. 289, 324, 361, and 400. Okay, so these are called perfect squares because if you do like the square root of them, so if you start with the perfect square and you do the square root, it's going to equal the number that's being squared. So for example, like the square root of 36 equals 6. The square root of 49 equals 7. So we just have to know that like that's why we're using our perfect squares, is because when you do the square root of them, they're going to equal a whole number. Okay, so that's how perfect squares work. So if you square something, it equals 4. If I do the square root of 4, it equals 2. I square 3, it equals 9. I do the square root of 9, it equals 3. So they're just like opposites, squares and square roots. All right, so in order to simplify, so these are called radicals. That's like the technical name. In order to simplify a radical, what you have to do is figure out what is like the biggest perfect square that goes into that number. So in order to figure that out, what I do is, so we're not really going to use 1 because all the numbers start with 1. What you're going to do is kind of just start at your smallest perfect squares. So again, my perfect squares are like 4, 9, 16, 25, 36, 49, 64. What I'm going to do is see if any of those numbers go into the radicand evenly. So the radicand is the number underneath the square root symbol. So I'm just going to see like what is the biggest perfect square that goes into 12. So all you have to do in your calculator is just start at the bottom. So I'm going to do 12 divided by my smallest perfect square is 4. Oh, that equals 3. So one of the rules with radicals with like square roots is I could break this apart using multiplication. So instead of 12, I could rewrite this as this is the square root of 4 times the square root of 3, because 12 is 4 times 3. So the reason that we want to figure out like a perfect square that goes into the radicand is because now I can simplify it. I know the square root of 4 is 2, so my final answer is 2 times the square root of 3. Okay, so the next one, the radicand is 32, so we're trying to figure out what is like the biggest perfect square that goes into 32. So what I'm going to do is I'm going to type in 32. Oops, let's clear this. So 32 divided by 4, that equals 8. I'm just thinking like, is there a bigger perfect square that goes into 32 though? 32 divided by 9 equals 3.55. 32 divided by 16 equals 2. So even though 4 goes into 32, there's actually a bigger perfect square. 16 is a bigger perfect square. So the way I'm going to break apart 32 is going to be 16 times 2. Okay, so 16 was my perfect square, so that's what I simplify. Square root of 16 is 4, so this would break down to 4 times the square root of 2. So sometimes there could be like multiple perfect squares that go into a number. You have to figure out like what's the biggest perfect square that goes into it. So 60, let's see, so I'm going to do 60 divided by my smallest perfect square is 4. I'm just going to start at 4 every time. So you do 4, you do 9, you do 16, you do 25. You just go up with your perfect squares from the last page. So 60 divided by 4, I get 15. We can try some other ones. Just keep going up. 60 divided by 9. That doesn't work. So what we're looking for is like one that comes out to like an even number. So like 60 divided by 9, that's not an even number. That's not like a whole number. 60 divided by 16, that doesn't work. 60 divided by 25, that doesn't work. Okay, so 60 divided by 4, that was 15, so that's the one that we're going to use. So this is going to be the square root of 15. Oh, so the square root of 4 times the square root of 15. I always like doing the perfect square first. So 4 times 15 is 60. That's where we got that from. 4 was a perfect square. So the square root of 4 is 2. Square root of 15. So all we do is like, that just turns into that because we're just simplifying it. So the square root of 16 is 4. That's all that turned into. All right, so 108. So again, in my calculator, what I'm going to do, I'm just going to start 108 divided by 4. It's 27. Sorry. And then if you keep going up, 108 divided by, I think this one is 36. You get 36 times 3. So this is going to be 36 times the square root of 3, and then if you simplify that, you get 6 square root of 3. So that is how you simplify perfect squares, or simplify radicals.